Ready when you are.
Dave Ridley, product manager from the UK.
That's me.
I'm saying what you. I've got to remind myself what you are. Hello again. My name is David Watts, and I have with me Dave Ridley from. Hello again. My name is David Watts, and I have with me today Dave Ridley from the UK, and we are going to go through the new IBM Flex System x240 M5. This is a new server that goes into our Flex System chassis, and it has the new Intel Xeon E5-2600 V3 processors, the brand new ones. So let's go through. We'll go through the front of the server, then we'll open it up, have a look inside, and show you all the bits and pieces. And we have a few options to show you as well. All right. So at the front of the machine, we have the usual connectors you see in Flex System. A USB 3 connector at the front, and this is a KVM connector for a keyboard, video, mouse, and serial port connections. We have two drive bays, 2.5-inch drive bays, and we'll talk about those in a moment. And over here is a power button, and next to it some LEDs for power indicators and system fault and so on. And this little doodah just here, Dave?
Yeah, that's really good actually, because quite often I go into data centres where people have stuck stickers over the air vents, which of course causes airflow problems, and so this is a way of putting labels onto the nodes without actually impeding the airflow. So you get a couple of the options to put stickers on this, and you actually get some in the packet as well.
Yep.
Cool.
And those get tucked away when you don't need them.
Yeah.
All right. Let's open up the unit and then talk about these drive bays, shall we? This is an engineering sample. You probably will tell from various bits and pieces. So the version that you'll get once the unit ships will look a little bit different.
Yep.
It won't have writing all over it like this one does. All right. So what we have in this system right here is two 2.5-inch bays. So these are hot swap bays. The bottom bay has a drive, and the top one is just a blank. These are hot swap 2.5-inch. Can be either hard drives or solid state drives, and use a mechanism you can remove the drive hot swap while the system's running.
Yep.
In addition to that, the server also supports, instead of the two 2.5-inch bays, 4 1.8s. Dave, do you want to go through those?
Yeah, that's right. So in fact, what we do to switch the machine across from the 2.5 to the 1.8 inch is that we actually replace a tray, or we insert a tray inside the system. So if I show you how we would do that, we take the 2.5-inch drives out here, and also this is a little blank that comes out. Mm-hmm. And what we need to do to add this in is, in fact, we replace one of the bezels that's on the front of the machine, and then we insert this tray, which has inside it, it's got the actual 1.8-inch drives. So pretty straightforward. Just pull that off there and clip this back on like that, and then the drive will go inside, or the tray will go inside.
So there are two sleeves.
Yep.
Each with two 1.8-inch drives, right?
And the other thing that we need to do when we put this in is actually change the backplane,
right? Because
the backplane at the moment is designed for two 2.5-inch drives, and so what we do is we replace that with a backplane that allows to have 4 1.8-inch drives, and that one just simply plugs in down there onto the board. Push the blue touch point, and then we slide this in, and it connects in, clicks in place, and we can bring the drives out the front here as you would normally.
Mm-hmm. And if you had a second sleeve, you'd insert that at the top?
Yeah, we've got another one that can go in there if necessary, and this just goes on the front to cover it up, like so. And if I put the drives in properly, it would click in correctly. There we go. So,
yes, all right. So as well as these two options, the 2.5-inch hard drive and solid state drive, or the 4 1.8s, we have this new PCIe hard drive.
Yes.
This is the NVMe format.
Express.
Yeah, NVM Express. Yes. This is a unit from Intel, 800 gigabyte solid state drive. Now the difference, if you compare this to a traditional hard drive, same form factor, the difference is that rather than a SAS interface, this one's a 6 gig SAS interface, it's actually a PCI Express interface.
Yeah.
And these drives connect directly to the processor. The connections look very, very similar. The key aspect are the pins on the top side. These, of course, will require a different backplane again, and there'll be options for that. But basically, the PCIe drive takes the place of one of the 2.5-inch drives. It's a hot swap unit, just like the hard disk drives. But it's a solid state drive, high performance, and the key thing is with these, very low latency.
Yeah, it's the latency that's the real key difference.
And there are a variety of sizes. The current maximum, I think, is 800 gigabytes. Yep. That's what this is. So that's another option that's available to you as well. Right, so what else do we have?
Probably worth looking at the machine itself, yes, and looking at the memory. Right,
so we have two processors. One here, this is processor number 1, and processor number 2 would go here. This unit only has one processor, so this is just a blank that's installed just to maintain airflow. Under these air baffles, we pop those out. You can see there's the memory DIMMs. So these are Intel Xeon E5-2600 V3 processors, up to 18 cores each processor, and they connect to the memory buses at memory speeds up to 2133 megahertz. There are 24 memory DIMMs, so 12 memory DIMMs per processor, right?
Yep.
And these are DDR4 memory DIMMs that do operate up to 2133 megahertz. 3 DIMMs per channel, 4 memory channels out of each processor, so for a total of 24 DIMMs. And if you use, for example, the 64 gig LR DIMMs,
yep,
those will get you up to a total of 1.5 terabytes of RAM. So a really significant amount of memory capacity.
Huge amount of memory in a 2-socket server.
Yeah.
Yeah.
Yep. So that's the main memory and processor subsystem. So looking further back, so this little device here. What's this little connector here? This little adapter here, Dave?
So this is a SD media adapter, and what this allows us to do is where we would have had in the past, for example, a hypervisor installed on a USB key. What we're able to do here, in fact, is operate in a mirrored environment using SD cards for the hypervisors, so you can boot the system off of that. This is an option that can be added. We've added it here. So what this has is it has 2 sockets on it for SD card, and we're going to support 2 32 gig SD cards that can be plugged in. This is an early unit that just has some test SD cards in here. So we'll have 32 gig SD cards that can be installed, and we'll support different operating systems on those. I think one of those is going to be ESXi from
so there'll be options you can buy where the VMware vSphere is already loaded on the cards.
Yes.
You can also buy blank cards, and this device is quite flexible in that it's designed that it can support, as well as VMware vSphere, things like Tool Center or Server Guide, any of the support tools that are available, because the drives that are presented from this adapter are visible to UEFI as bootable devices.
Yes.
Yeah.
So we can boot off it.
Yeah. Now there's 2 of them, right? Now, why is that?
So we can do RAID 1. So
okay,
for redundancy. So if one should fail, the other one takes over, and that's all carried out seamlessly.
Right. So that's the SD media adapter, an optional feature. And it screws down. We actually unscrewed it before we started just to make it a little bit easier to pop it out.
Yeah. And it sits below where we would put a MES card. One of the I/O adapters.
One.
So one of the Ethernet adapters would plug in over the top of that, and the 2 can coexist at the same time. One thing you're seeing here on this particular machine is because this is an early test unit, it has what we call a periscope adapter or a connector here. But that won't actually be on the production units. Normally the I/O would be delivered by a MES card or an I/O adapter. The I/O adapter just plugs in on top. So the 2 don't interfere.
And just like other Flex System servers, this machine supports 2 cards, one here and one here. So we've got here a 10 gig Ethernet card, and this one's a 16 gig Fibre Channel card, and that would go into this socket here, right? Yeah. Actually, before you pop it in, I want to also point out too that this port here is the connector that you would use to connect to one of the expansion units as well. So the X240 M5 supports the PCI expansion node and the storage expansion node.
So the pen and the send.
Right. So the pen supports 2 high IOPS adapters, for example, or 1 GPU or coprocessor. And also additional connectors at the back for 2 more of the standard Flex System I/O adapters. And the SEN, which also would be an option for the expansion port, is an additional 12 drives, 2.5-inch drives.
Yes.
So
hot plug storage expansion unit that you can pull out and swap the drives with it live.
Yes. Yeah. Okay, so the second I/O connector is here, so you can put an adapter such as the 16 gig fibre channel adapter here. Just goes into the socket like so. Yeah, so there you have it.
Nice and simple.
All right, so
so one of the other things that we didn't quite mention on the front panel when we were looking at this is a change that we've made around the light path. And on the existing machines that you've seen up until now, light path panel has been on the top here. But on this machine, what we've done is we've moved that light path panel from the front panel inside the system between the processors down here. And so it tells exactly the same story, exactly the same number of LEDs, etc. But we've just actually moved the location inside the server. Functions.
So if the server has a fault, then the front LED, the front arrow light will light up. You can then power off the machine, pull it out. You can press the power button down while the machine is pulled out. There's a battery that will still drive that, and that will light up the light path diagnostic panel and tell you that it's a system board fault or a memory fault. And there are additional LEDs on the system board that will show you which specific component has failed, whether it's a memory DIMM or some other component, or this attached storage expansion node or PCI expansion node.
Right. Every single memory DIMM has an LED against it, so it makes the mean time to repair very short, very quick.
Okay, so that's the internals of the system. Let's flip it round and we'll look at the back connectors as well, shall we? So what do we have here, Dave?
So basically this is the part that presents to the inside of the Flex chassis and connects up to the midplane. And there's various different connectors on the back of this system that pick up different things. So first of all, we've got the power connectors that pick up the power that powers the system, and that's distributed around the midplane. So the power supplies that come in at the back of the chassis will drop down the voltage down to the internal 12 volts that goes around the system. Then we've also got here a dedicated management connector and other signals that come in. So there's various I2C bus signals that are linked through on this as well. And then there is also the I/O adapters that are picked up, and depending on which card you obviously put in, and depends on what is actually connected through to which switch you've got at the back or I/O module that you've got at the back of the chassis. These I/O adapters have a theoretical capability to give you 16 channels of I/O in total, so 8 channels through each adapter that can connect through to the back of the system.
So this goes to the midplane of the chassis.
That's correct.
And then also on the other side of the midplane are the connections inside the chassis to the I/O modules, the switches.
Right. Yep.
So either Flex Fibre Channel or 10 gig Ethernet, 40 gig Ethernet, InfiniBand.
Pass-through modules.
Yep.
Fabric extenders.
Yes. So a variety of I/O modules that are available for the Flex System chassis that connect into the midplane as well from the back of the chassis.
That's right, and in fact in the Products and Technologies book there are some diagrams that show exactly how all this is wired together, what connects to what, and what the bandwidths and throughputs are.
Yeah. All right, so that's the IBM Flex System X240 M5. I hope you found the video useful, and we'll see you next time.
We really do know what we're doing, really.
Is this upside down? Oh no, that's right.
For God's sake.
You know what we're doing? Is this upside down?
You got a hammer?